Number 4, we are going to find the dimension of the rectangle with the largest area, and it says that we want the base to be on the x-axis, and the two vertices are above the x-axis, and they are on the parabola. Y is equal to 12 minus x squared. And if you haven't done so already, you should definitely try this question first before you continue watching the video. Especially you have seen 3 examples already. You should be able to do this on your own. Done? Okay, let's go ahead and write down what we know. We have a parabola, so let's go ahead and draw that parabola first. 12 minus x squared. The minus x squared is an open down parabola. This 12 tells us to drag the parabola up 12 units. So we will have a picture like this. Okay, we want to have a rectangle, and it says that the base is on the x-axis, so it will look like this. And the two other vertices are above the x-axis and lying on the parabola. That means we should just go up like this, like that. But here's the deal though. If I drew the rectangle like this, then you know that the blue one and the red one, they will have different areas. So we are trying to see how to draw it so that the area of the rectangle is the biggest. And now here's the deal. That's label. This right here will be x, and this right here will be y. And notice though, the x is only this part. I should really emphasize that, and that's the y. All right. So let's see. We know that y is equal to 12 minus x squared. It's nice. It gives us an equation already. Now we want the maximum of the area. What's the area of this rectangle based on our labeling? Well, here we have x times y, but we want the whole thing, so we have to double that. That's why it's 2 times x and y. Be careful with this. Now you are pretty much ready to go. Put the y here, and then let's just see. We will have a as a function of x, and that's 2 times x times y, which is 12 minus x squared. And then do the algebra first. So a of x is equal to 24x minus 2x to the third power. All right, take the derivative. We get the derivative of 24x, which is 24, and then this derivative will give us 6x squared. And now, of course, we'll set this to be 0, and let's put this to the other side. So we get 24 is equal to 6x squared, and divide both sides by 6, we get x squared is equal to 4, and take the square roots on both sides, and we just need to consider the positive. So the critical numbers that we care in this case is just x is equal to 2. If you say x is equal to negative 2, then you are looking at the other direction. And maybe you can still work that out, but 2, you know it's going to be the answer. Anyway though, a double prime for the second derivative. Take a look at this. The derivative of 24 is 0, and the derivative of this is negative 12x. The second derivative, when x is equal to 2, we get negative 12 times 2. And that will be negative 24, which is less than 0. And now let's go ahead and justify that. You see, the first derivative at 2 is 0, and the second derivative there is less than 0. Therefore, there is a maximum at x is equal to 2. All right, we want the dimension of the rectangle. Be careful with this. Y will be 12 minus x, and then square that, which is 12 minus 2 squared. 2 squared is 4, and then, and then 12 minus 4 is 8. Good. But be careful with this though. The dimension is not 2 by 8. Rather, we will have to account for the whole thing. The base is 2x, right? For the rectangle. So you actually have to double this. So the answer is actually 4 by 8. All right, so that's the area. That's the dimension that will give you the biggest area, 4 by 8.